Oh, this is great. What a great story. Wow. Hi. I was taking a little break and reading one of my favorite magazines. You know, this magazine reminds me of an interesting question that involves figuring out what is fair. Fair is sometimes difficult to define. Let's take a look at an example and see what we think. So, in this case, we have 40 students in the school show choir that sold a total of 104 magazine subscriptions to raise money for a trip. Now, as an incentive to participate, the teacher will award a prize to one student in the choir. Our challenge: describe a method of awarding the prize fairly. And let's see if we can use probabilities to explain why this method is fair for the students that we are given. So, first of all, let's identify what we know for sure. So to be very clear on the important information, here are the key facts. We have 40 students. They sold a total of 104 subscriptions, and there's only one prize, and so only one winner. Okay, so to be fair, seems students who sold more subscriptions should have a better chance of winning than students who sold fewer. And that's what we're going to think of as being fair here. And so the number of chances of winning should equal the number of subscriptions sold. So we have 104 subscriptions. What we could do is literally number them from 1 to 104, and then just give out to each person tickets to represent the number of subscriptions that they themselves sold. So if we kind of move on, we have, let me show you what I've got here, because I'm going to show this to you. You think I can't do it. I'm telling you I can, no matter what people say. And they do wonder about me. The students sold 104, so let's assign a unique number from 1 to 104 for each subscription sold. And then each student gets as many numbers as the number of subscriptions he or she sold. So for example, if we take a look at 3 students, so Keisha sold 4, Stefan sold 0, and Lourdes sold 12. Then what we would do is Lourdes would get 12 numbers because she sold 12 subscriptions and so forth. Now, if we do that, we can now figure out some probabilities, which was, of course, part of the challenge here. So since the 4 subscriptions were sold by Keisha, then we have numbers, let's say 1 through 4, and that means that she has 4 tickets out of a total of 104, so that's 4 over 104, which is approximately 0.038, or about 3.8% chance of winning. Stefan sold 0. He has no tickets. There is no way he's going to win. It's 0 over 104, so he has a 0% chance of winning. And Lourdes has 12 sales, so let's say she gets numbered 21 through 32, just say, but 12 numbers. And so she has 12 possible ways of winning out of a total possible number of 104 equally likely ways of winning, and that works out to be 11.5%. So you can see that, in fact, the percentage goes up the more you sell, which, of course, seems fair. Now, what would we do from here? What we would do from here is we would say, okay, we need to then randomly generate an integer from 1 to 104, say using a graphing calculator to pick the winner. And so, for example, if the number 28 was generated, then in fact that would be one of Lourdes's tickets. So, and then she would win. Okay, so now, is this fair or not? Well, I think it's actually pretty fair. And let me just say why. So first of all, this seems fair because it gives everyone who sold a subscription a chance of winning, but the more tickets that you sold, then the greater the chances are that you win, which seems about right? If you work really, really hard to sell lots of tickets, then you might get an edge up. Now, there's some other things that we might want to consider, alternates. So let me just introduce some alternates. So a prize could be awarded to the student who sold the most subscriptions. So the absolute, just whoever had the highest number of subscriptions, that person wins automatically, and we don't do this lottery type thing. But this might not be possible. First of all, if one student sold this, more than one student sold the same number. So suppose that the maximum number of tickets sold, let's say, were 22, and let's say there were 3 people that each sold 22 tickets. Well, then who's the winner? There's only one prize, and they can't split it, so that becomes a problem. It also might not be fair because maybe some students just had better access to buyers than others. With our way that we just analyzed, everyone has a chance of winning, but the more that subscriptions you sold, the higher your chances are. But everyone actually could potentially win, even if someone just sold one. It only takes one ticket to win. Yet another possibility that we might want to consider is to actually make the chance of winning proportional to the dollar amount of the subscription sold. And that, in some sense, to me, if in fact the subscription dollar amounts for each subscription were the same, it'd be equivalent to the way that we used. But if in fact maybe different subscriptions cost different amounts, then in fact this would kind of skew things a different way. And then we're measuring kind of on the maximum amount of money brought in. The more money you brought in, the more likely the chances are that you'd win. Well, either way, you can see that there's some interesting philosophical questions that arise when we think about fairness and trying to find things and methods that are fair. Turns out this is very vexing, and at the advanced level of mathematics, people talk about fairness in sharing things, or in this case, how to distribute just one prize. Have fun finding the fairness in your life, and I'll see you soon.